Alright, so using the factor theorem, this is the same slide we had up the other day, so I'm not going to leave it up for too long. But if we remember our remainder theorem, if we plugged in and got 0, or if we plugged in, so if we divided something by x minus c, and we plug in c, whatever we spit out was our remainder, and if the remainder is 0, then it means that this is a factor. It factors out nicely, right? If you don't have a remainder, then you have this times some nice polynomial q of x, right? Where the remainder is 0, so you have another polynomial after that with none of the like plus, 3 over 2x plus 1, none of that, right? Because no remainder. So then x minus c is a factor of f of x, and it works the other way around, right? If this is a factor, then f of c is going to be 0. That comes straight from our remainder theorem. So, if you factor, all this is essentially saying is, and it doesn't kind of specify, but if you have a cubic, right? If we have x cubed plus, whatever the rest is, I don't know, 3x squared minus 10x plus 11, whatever it is, if you can factor out an x minus c, then the other factor is going to be an x squared something, right? Because you're going to need x times x squared to get x cubed. And so on, like if it was x times x cubed, that would go x to the fourth if this was x to the fourth. And so this factor theorem / the remainder theorem really helps us to determine if things are a factor or not. So if f of x equals that long thing and x plus 2 is a factor of f of x, then find all the zeros of f of x algebraically. So this is going to need some factoring, but the first thing is we know x plus 2 is a factor. What does that mean? It means x plus 2 times some polynomial equals this whole thing, that whole f of x, right? And so we need to find this q of x. And so we're going to do division to find out what it is. If you're more comfortable with long division, you can do it. But I am going to do our cheater synthetic division way, right, where we put the coefficients here. That's a horrible 8. 4, 48. And then we put c here, which in this case c is -2, right? It's the opposite, right? Because we do x minus c, so if it's plus c, we're really plus a negative. And then we draw this, bring the 1 down, multiply, -2 times 1 is -2, add, multiply, add, multiply, add. So we have verified that this is a factor because our remainder is 0. But what this means is here we have x squared minus 10x plus 24, right? And so what this is saying is x plus 2 is a factor, and we get this, that x plus 2 times x squared minus 10x plus 24 equals this whole f of x. So this f of x and this are the same thing, just written differently, right? And we want to find the zeros, or we call them the roots, or you could basically think if this was equal to 0, that's what that means. And it's a good thing we reviewed this at the beginning of the semester, right? That means we have to factor this, so x plus 2, and then we can factor this thing, right? We can split that up into two different binomials, and you guys are used to this little x right here, and you're saying what multiplies to 24 and adds to -10, and you find the two numbers that do that, -6 and -4 do that, right? -6, -4 add to -10, and they multiply. Negative times a negative is positive 24, so that means we get x minus 6 and x minus 4. And then I believe we also covered our zero product property. Right now we can, wherever there's multiplication, so here and here, we can split it up and set each of these equal to 0. And then just solve, right? Subtract the 2 over to get x equals -2. Add the 6 over to get x equals 6. And add the 4 over to get x equals 4. And so there's all of our answers. Here's all of our zeros. And the reason that works is because we have this whole thing set to 0, right? Because we're finding the zeros. And when you have 0 times anything is 0, right? So if I make any of these things in parentheses 0, it works, right? Because x plus 2, if x is -2, -2 plus 2 is 0, times, it doesn't even matter what these other things are, right? That's why it's important to split it up where there's multiplication. 0 times anything is 0, and it makes this true, right? If x is 6, 6 minus 6 is 0, times it doesn't even matter is 0. So it works. 4 minus 4, 0 times anything is 0, so it works. And graphically what this means, so maybe let me actually go to, let me load up like Desmos or something real quick. And let's put this in to Desmos. So we have y equals x cubed. What was the rest? Minus 8x squared plus 4x minus 8x squared plus 4x 48. So the zeros are where it crosses the x-axis, and you'll notice we're at -2, 4, and 6. Woohoo! Which is what we got. So that's what that means graphically, finding the zeros. Let's do a couple more. So if x minus 2 is a factor, then find all the zeros of the x algebraically. So again, I'm going to find out what it factors into by dividing by x minus 2, and I'm going to do it the cheater synthetic way, where c is 2, and then my things are 1, 8, 1, -42. Bring it down. 2 times 1 is 2. Add them. 2 times 10 is 20. Add them. 2 times 21 is 42. Add them. And hey, it turns out that x minus 2 is a factor because we get remainder 0. So what that means is we have x squared plus 10x plus 21. And it means that our factor x minus 2 times this thing up here is the same thing as our original f of x, right? That's basically like if we did, 24 and we divided it by 6 and we got 4, right? Now we're just saying, okay, 6 times 4 is 24, right? Instead of writing 24, this is like writing it as like 6 times 4, except instead of writing x cubed plus 8x squared plus x minus 42, we're writing it as x minus 2 times x squared plus 10x plus 21. That's basically what we're doing. Now, we're finding the zeros, so set this equal to 0, and then it helps to factor this out again, that x minus 2 can stay. This can factor, or you could use the quadratic formula if you remember it, or any other things you may remember. And you guys love the little diamond thing here, where you multiply to that last number, 21, and add to the middle number, 10. Right, what two numbers do that? 7 and 3. So we're going to get x plus 7, x plus 3. And then from here, wherever you see multiplication, split it up, set them all equal to 0, and then add the 2 over, subtract the 7 over, subtract the 3 over, and those are our 3 roots, or the 3 zeros. And you might see the pattern, right? The x is just kind of the opposite of what's here because 2 minus 2 is 0, negative 7 plus 7 is 0, so that's why it's kind of always the opposite. But this is a good habit to do this line because if you end up getting something like, I don't know, 2x plus 3 times x minus 5 equals 0, right? Well, this one's the easy one, x equals 5, right? But then this one here, it's not difficult, but like maybe if you don't do this, you might rush it and um, get it wrong. So right, the 0 here for that one would be negative 3 halves. Which is a little wonkier than this. So that's why it's just a good habit in case you get anything like that. Okay, let's do one more. So if f of x equals x cubed minus 5x squared minus 8x plus 12 and f of 6 equals 0, then find all the zeros of f of x algebraically. Well, due to our factor theorem, we know that if f of 6 equals 0, then x minus 6 is a factor. Right? That's going back to this guy here. Right? If f of, and then I'm replacing c with 6, then x minus 6 is a factor. So, again, I'm going to find out what it factors into, and I'm going to do the cheater synthetic division way, where 1, negative 5, negative 8, 12, bring it down, 6 times 1 is 6, add is 1, 6 times 1 is 6, add 6 times negative 2 is negative 12, and that's a good sign we did it right. So that means we have x squared plus x minus 2, which means that we have x minus 6, right? This f of 6 equals 0 means that x minus 6 is one of the factors, so x minus 6 times x squared plus x minus 2 equals 0. And then if you get comfortable with it, right, you don't really need to do the diamond. You say what multiplies to negative 2 and adds to 1. Well, that'll be plus 2 and minus 1. Right? If you need to do this, that's fine. What multiplies to negative 2 adds to 1. Right? And you really only have one option because the only thing that multiplies to 2 is 2 and 1, and then you just have to pick the right one, right? If we want to add to positive 1, that 1 should be negative. And then I'm not going to split it all up here, but the solutions would be 6, negative 2, and 1 because that's what would make each of those things 0 or the whole equation